I had a fascinating conversation earlier this week with someone who was asking me about developments of this new Co-pilot Enabled PC or laptop that Dell just announced at their big conference. And their concern was, well, aren't laptops not powerful enough to power AI, right? Which is in the current state, yes. And then two, what if there's no internet connectivity? How do you deal with that lack of being able to query the model and get a response back? So kind of thought about it, and there's an analogy here with IoT, which is an area that I hadn't been involved in a number of years ago. It was really thinking about, with IoT, you had the problem of connectivity to the cloud with the sensor data, right? Or some data you're collecting in the field. And then being able to action that in the field rather than send it back to the server, get some decision, and then bring it back to the edge, right? The edge just being simply the edge of that computer system. Now, the way to get around that was hardware got smaller, software got lighter, and that allowed them to do more of the computing at the edge. So it got me thinking about AI models. And when you have something like ChatGPT 4 Turbo or Gemini larger models and things like that, the problem you run into is it's almost too much power for everyday AI. Think about what you use it for. You're not processing all of the Bureau of Labor Statistics information for the last 100 years to build some model, right? No, you're getting ideas for a paper. You're building a presentation. You're looking to write an email to a colleague for a difficult conversation, right? So these are fairly lightweight applications, still pretty cool, but lightweight. So what they're doing with these models is they are paring them down and creating lightweight models. Then they're putting that to work on chip technology that's actually quite incredible. If you look back about, I would say 2018 or 19, I was at a conference for ARM, which is a major chip maker in San Jose, California. And they introduced the Snapdragon chips at that conference. And that allowed mobile chip technology to be used in personal computers, right? Doesn't sound revolutionary, but there's a ton of technical stuff around heat transfer, heat generation, latency, different things like that, that really was a game changer. And only in the last maybe year or two has that really come out. So, same thing with IoT. The language model developers are stripping down these overpowered models for daily use, right? You don't buy a U-Haul, you rent a U-Haul, you buy a Honda, right? So if you have a large problem and you have a big task, you may need to go and use that large language model in the cloud using all of that immense computing power. But for everyday use, you're really more looking at squishing that model down, something that can be run on the edge, your laptop, your computer, for everyday use, right? And that's going to do a couple things. One, it's going to increase the speed with which you can get answers. Two, you don't have to worry about connectivity. So if you don't have internet or you don't have cell service, fine. That allows you to do things in more remote places as well. Three, it allows you to integrate more local apps more quickly and more inexpensively and not use those valuable resources in the cloud for everyday queries. So I think it's a fantastic thing, right? I think that allowing us to use these more local models is going to be where the industry is going to go for quite some time here, especially with day-to-day AI. And I think we'll find that more certainly in project management, where we have a lot of very quick, very easy, very streamlined processes that we want to improve with AI. And it doesn't necessarily take the amount of computing power that a cloud-based model could bring to bear. So I think it's a good thing. I think it's a fascinating question. I'm probably going to dig deeper into that at a later date, but I just wanted to share some thoughts. Thanks.